Yes. Today we discuss about limits for trigonometric functions. In the first video we discussed about the concept of limit and various types like factorization method or L'Hospital method or rationalization method. We can find out the limits of the given functions. Now today we discuss about limits of a trigonometric functions. First, we'll discuss about sandwich theorem. Sandwich theorem. The sandwich theorem is very important in limits in trigonometric functions because sin x by x is equal to 1, tan x by x is equal to 1. If it extends to 0, sin mod x minus a by x minus a does not exist. The simple concepts depends only on this theorem, that is sandwich theorem. The definition of sandwich theorem is if f of x, g of x and h of x are three real valued functions on the same domain, limit x tends to a, f of x is equal to limit x tends to a, h of x is equal to 1, then limit x tends to a, g of x is also 1. This is called as sandwich theorem. That means the first function and third function limit x tends to a is equal to 1, then automatically the middle function limit x tends to a, g of x is equal to 1 because these functions sandwich by these two functions fx and hx. Now limit x tends to a, g of x is equal to 1. Here by taking the graphical notation also I have to observe here, if you take three functions fx, gx and hx, this is mutually perpendicular lines. Here this function is called fx function and again this function is called gx function and again this function is called hx function. These three functions on the same domain, then f of x less than or equal to g of x less than or equal to h of x. Then by g of x is sandwiches by f of x and h of x. Here we observe the graphical notation, f of x is less than g of x is or equal to less than h of x. Then we know that limit x tends to a, f of x is equal to limit x tends to a, h of x is equal to 1. Automatically limit x tends to a, g of x is equal to 1. By using the sandwich theorem, we can derive a simple notation, limit x tends to 0, sin x by x is equal to 1. If you know the theorem, many problems that formula is useful to derive the limits in trigonometric functions. By using the sandwich theorem, just you derive now. From this, if three functions f of x less than or equal to g of x less than or equal to h of x, we know the notation of limit x tends to 0, sin x by x is equal to 1. This is very important formula in trigonometric functions. Because sin x is positive, always lies between the maximum and minimum values -1 and +1, and the condition is 0 less than x less than pi by 2. That means the x value lies between 0 and pi by 2. If it extends to 0, sin x by x is equal to 1. By proving this equation, just we take a unit circle here. Unit circle in the sense the radius of the circle is always 1, that is called unit circle. When you take any point here, see, this is OA is the radius. Units means it is 1. And join OC and OA. by extended OC to this side. This should be AB, and here D is perpendicular. Here CD and AB are perpendiculars to OA. Here CD and AB are perpendicular to OA, and OA is equal to OC is equal to 1 because it is unit circle. Unit circular sense, the radius of the given circle is 1. OA is equal to OC is equal to 1. Okay, by proof this, first we observe this diagram. OAC is one of the triangle and OAC is a sector, and again OAB is another triangle. Here in this diagram, three figures we obtained. One is OAC is one triangle, second OAC is sector, and OAB is another triangle. By observing this, area of triangle OAC is less than area of sector OAC is less than area of triangle OAB. By observing these three, triangle is less than sector and sector area is less than triangle OAB. By observing this triangle, area of OAC, we know that half into base into height. Half into base into height. And area of sector formula, x by 360. 360 can be written as 2 pi r square, that is OA square. And again area of OAB, area of triangle half into base into height. Thus by concluding this, here in 3 halves are cancelled here. OA into CD, OA is unit radius is 1. Now this is CD less than, here pi cancel, and in both three cases also OA cancel. Here x is remaining. In OA square 1 OA is remaining here, and here half also cancelled, OA cancelled, we get AB here. Now from this we conclude that CD less than x into OA less than AB. Now from the diagram we find out the values of CD and AB, then we get the answer. We want CD here, this is the opposite side. By the angle you take as x here, this is opposite side and this is hypotenuse. From this triangle, sin x is equal to CD by OC. Now CD by OC is nothing but OA, because OA is equal to OC is equal to radii. Therefore, CD is equal to OA into sin x. CD is equal to, find out CD is equal to OA into sin x. Now we have to find out AB side. In this triangle AB, we know OA, therefore opposite to adjacent side, we take it as tan x here. Tan x is equal to opposite side by adjacent side, that is equal to AB is equal to OA into tan x. Now I have to find out CD and AB and substitute here. C in the place of CD, we write OA into sin x less than x into OA less than OA into tan x. Now we know that the condition is 0 less than x less than pi by 2. It should be positive, sin x is positive. Therefore, we denoted here we will find out dividing by sin x on both sides, and OA also it is equal to 1 because of it is unit circle. Therefore sin x less than x less than tan x. Sin x less than x less than tan x. Now divide by sin x here. Divide by sin x. Divide by sin x. Just we have to know that sin x by x, sin x by sin x less than x by sin x less than tan x by sin x. Now it is 1 less than x by sin x. Tan x by sin x means sin x by cos x. It should be 1 by cos x. Sin x cancel out. Now by reciprocal here, cos x less than sin x by x less than 1. Here by using sandwich theorem, here cos x and 1, cos x is equal to 1, limit extends to 0. These two are sandwiched by sin x by x is equal to 1. Then we apply limit extends to 0 of cos x. Limit extends to 0 of cos x is nothing but cos 0 is equal to 1. Now apply limit here. Limit extends to 0. Cos x is equal to limit extends to 0, 1. This should be a constant. Here cos 0 is equal to 1. 1 is equal to 1. Now these two are sandwiched by sin x by x is equal to 1. Therefore, limit extends to 0. Sin x by x is equal to 1. This is very important theorem, that is limits of trigonometric functions. While we solving in all trigonometric functions of the given limits, first this is the basic concept, sin x by x is equal to 1, or sometimes here we divide by x from this place. Tan x by x is also 1, because here sin x by x is equal to 1, and here x by tan x, here tan x by tan x 1, all divided by sin x. Sin x by x is equal to 1, and always here tan x by x also is equal to 1. Now this is the proof of sin x by x is equal to 1 whenever limit extends to 0. Now from this we learn the notations here. Limit extends to 0. Sin x by x is equal to 1. Limit extends to 0. Tan x by x is equal to 1, and limit extends to 0. Sin mod x minus a by x minus a does not exist. Does not exist, because we apply limits right hand side and left hand side. When you take positive, it is sin x minus a by x minus a, it is equal to 1. When 0 minus left hand side, right hand side is 1. Left hand side, mod of x minus a, negative means minus of x minus a, it should be minus 1. Therefore LHL not equal to RHL, then limits does not exist. In the same way, limit extends to 0. Tan x minus a by x minus a also does not exist. Does not exist, because it is also mod x. Whenever it is equal to mod x is equal to x, if x greater than 0, mod x is equal to minus x if x less than 0. When you take greater than 0, tan x minus a by x minus a should be 1. When you take mod x is equal to negative, minus of tan x minus a by x minus a minus 1. Therefore, LHL not equal to RHL. Therefore, limit does not exist. Now, from this, I learn few small problems regarding sin x by x is equal to 1, or beautiful problems are there once you check it first. A simple problem, limit extends to 0, 1 minus cos x by x square. This is very important. In the middle of any big problem, 1 minus cos x by x square you obtain. In this place directly we can write 1 by 2. You noted in your mind limit extends to 0, 1 minus cos x by x square is equal to 1. By proving this, limit extends to 0, 1 minus cos x means 2 sin square x by 2 by x square. 2 sin square x by 2. We know 1 plus cos 2a is equal to 2 cos square x. 1 minus cos 2a is equal to 2 sin square x. Here cos a in the sense x by 2, submultiple angles. Now here limit x tends to 0, 2 constant here sin x by x ఉండాలి. మనం నేర్చుకున్న ఫార్ములాలో లిమిట్ x tends to 0 sin x by is equal to 1. Here sin x by x. Here sin square here. Sin square means here squaring x square by 4. This is x. By squaring means x by 2 whole square. That is equal to x square by 4. But here only x square is there. Therefore dividing 4 into 4 we get the correct answer. Is equal to sin square x by 2 by x square dividing by 4 into multiplication by 4. Now limit x tends to 0, 2 into sin square x by 2 by x by 2 whole square into 1 by 4. Now this, you observe this sin x by x, sin square x by x square. Therefore, limit x tends to 0. This is 1. No need to write limit x tends to 0. We can direct answer 2 by 4. 2 by 4 is equal to 1 by 2. Therefore, in any problem, limit x tends to 0, 1 minus x by x square value is always 1 by 2. Everyone please note in your mind, 1 minus x by x square is equal to always 1 by 2, because that is standard notation. By using limit x tends to 0, sin x by x is equal to 1. Now another problem, limit x tends to 0, cos 7x minus cos 9x by cos 3x minus cos 7x. Here by taking cos c minus cos d, cos c minus cos d, we get the answer by numerator and denominator, or we take a shortcut also here. This is a and this is b and this is a and this is b. A shortcut is b square minus a square by b square minus a square. That in the sense 9 square minus 7 square by 7 square minus 3 square, 81 minus 49 by 49 minus 9, that is equal to 2, 32 by 40, that is equal to 8 by 10, that is equal to 4 by 5. Whenever cos 7x, cos 9x are here, this denominator is not there, just by 2, just we apply b square minus a square by 2. B square minus a square. Whenever cos is given, just b square minus a square. Very easy. Or we apply cos c minus cos d minus 2 sin c minus d by 2 cos c plus d by 2. We apply the formula. Again we get sin x by x formation. Then we get the value. Of course here this is cos x. We no need to get sin x. But cos c minus cos d we get sin x. In the cos x is substitute x is equal to 0, we get the answer. This is the shortcut. B square minus a square. Whenever causes a and b are different, b square minus a square. This is also very important shortcut. And sometimes they are given sin 3a cos 3a formulas also, that is 3 sin x minus sin 3x by x cube. We observe that here sin 3x is one of the important formula. We apply that formula, we get the answer. Limit x tends to 0, 3 sin x, sin 3x formula 3 sin x minus 4 sin cube x by x cube. Now limit x tends to 0, 3 sin x minus 3 sin x plus 4 sin cube x by x cube. For limit x tends to 0, 3 sin x cancel, 4 sin cube x by x cube. Now this is answer is 4. Because this is sin x by x, we convert as sin x by x whole cube here. sin cube x by x cube, limit x tends to 0, sin x by x is equal to 1. Therefore, 4 into 1 is equal to 4. Here by using the notations, here also cos 3x, whenever cos is there, tan 3x or sin 2x or sin 2, whatever the trigonometric formulas we have to apply, then we substitute x is equal to 0 or sin x by x is equal to 1. In any notation, we convert into sin x by x or tan x by x is equal to 1, we get the answers. Now simple, this is also very important. Number of times NCERT examination will come. Sin square x by y minus x. Now JEE and advanced, after this class we discussed about previous years 25, 24, 23 JEE mains problems. We will explain. First know the basics of these all points and simple formulas by using the applications. Then enter into the JEE mains problems and advanced problems. Because if you don't know the basics, sometimes in middle of the problem, these basics are applied, you get the answer. That's why you know the basics and small important problem related to NCERT models. Here y tends to 0, here y minus x both are there. By using L-Hospital method, easily we can find out. By L-Hospital, because y tends to 0 here. Therefore, by using L-Hospital, because with respect to y only, not with respect to x, because they are given limit y tends to 0. Therefore, here limit y tends to 0, sin square x means 2 sin y cos y. 2 sin y cos y, limit y tends to 0. Here 2 sin y as to y you have to apply. I think this is y tends to x. If you write y tends to x, here y minus y is equal to 0, then we apply L-Hospital rule. This is y tends to x. Now, in the place of y, you write x, 2 cos x and sin x. We get sin to x. We get sin to x. Here y tends to x. In the place of y, you write x minus x is 0. Numerator by denominator, it is 0 by 0 formation. Therefore, we use L-Hospital rule by differentiating numerator. Sin square y is equal to 2 sin y into cos y. Now y tends to x, in the place of y, you replace x, 2 sin x cos x. We get sin to x. So this is very simple problem by using L-Hospital method. And if you want to go some big problem, limit x tends to pi by 4, very important, cos x minus sin x by pi by 4 minus x into cos x plus sin x. Limit x tends to pi by 4, cos x minus sin x by pi by 4 minus x into cos x plus sin x. Whenever limit x tends to pi by 4 means we convert the total problem into pi by 4. Here by multiplying with pi by 4 here or root 2, directly we get one sin a plus b cos sin a minus b formation. Here root 2, 1 by root 2 cos x minus 1 by root 2 sin x. 1 by root 2 sin x by pi by 4 minus x into cos x plus sin x. Now limit x tends to pi by 4. Root 2 into sin 45. Sin 45 cos x minus cos 45 sin x by pi by 4 minus x into cos x plus sin x. Now implies limit x tends to pi by 4. Root 2 into sin a cos b minus cos a sin b sin a minus b sin pi by 4 minus x by pi by 4 minus x into 1 by cos x plus sin x. See, the total problem I convert into sin x by x model. Sin pi by 4 minus x by pi by 4 minus x. If it extends to pi by 4, this value equal to 1. Therefore, root 2 into 1 by cos pi by 4 plus sin pi by 4 root 2 into 1 by 1 by root 2 plus 1 by root 2. The final answer is root 2 into, by taking root 2 the numerator, 1 plus 1 2. Here 1 plus 1 2 by root 2, root 2 by 2, just by reverse. Root 2 into root 2, 2 by 2, the answer is 1. This is very easy problem. Whenever the problem is in pi by 4s, if it extends to pi by 4 means we convert the problem into pi by 4s. Here we multiply root 2 in both numerator and denominator and we get this formation sin x by x is equal to 1. Then you apply extends to 5 by 4, 1 by root 2 plus 1 by root 2, 2 by root 2, root 2 by 2, root 2 to 2 by 2 is equal to 1. This is also very important problem. If you want one more very simple problem, or cos e minus cos d, or limit extends to 0, it's also very important. 1 minus cos ax square plus bx plus c, advanced ఇస్తూ ఉంటారు ఈ మోడల్స్, x minus alpha whole square. But we know 1 minus cos x by x square is equal to 1 by 2. In the same way here we apply, if you know ax square plus bx plus c is a quadratic expression, a into x minus alpha into x minus beta, you know this expression. Yes, you apply this, limit extends to 0, 1 minus cos a into x minus alpha into x minus beta by x minus alpha whole square. It is 1 minus cos x by x square, we get 1 by 2. Now here limit extends to 0, 1 minus cos ax by x minus alpha whole square. We know that 1 minus cos x by x square. Here cos x means x minus alpha. Here x minus alpha whole square. Therefore, just cos x by x square means 1 by 2, you know. Just square here. Just here also a constant. We write down a square, that is equal to a square by 2 into x minus beta. Because here 1 minus cos x by x square. Cos x means a into x minus alpha. Here x into x minus alpha, or here x minus beta also whole square. We multiplied with x minus alpha square and 1 minus beta square and a square also we get easily, because cos x here. This is also cos x. Square, cos x by x square. Here a means a square. That means we have to multiply here 1a. Because a cancel, again a will get. Here x minus beta, we multiply with the x minus beta whole square. No confusion, a square into x minus beta whole square, here a square into x minus beta whole square, both are cancelled, again we get the same. Now our conclusion is 1 minus cos x by x square means 1 by 2. Here a square into alpha minus x minus beta whole square. This is the answer, a square by 2 into x minus beta whole square. There is no confusion. We know that limit extends to 0, 1 minus cos x by x square is equal to 1 by 2. By applying this 1 minus cos x, x means a into x minus beta into x minus alpha, by x square. Already x minus alpha whole square will be given. And we have to write remaining 2 here, a square into x minus beta whole square. At the same time we multiply, both are cancelled, we get the original fraction. Then now we apply that 1 minus cos x by x square is equal to 1 by 2. Here 1 by 2 into a square into alpha minus beta whole square. This is also very important notation. And evaluation to the exponential and logarithmic functions. evaluation of exponential and logarithmic functions. These plays are also vital role in limits in trigonometric functions. This is e power x, limit x tends to 0, e power x minus 1 by x is equal to log e base e is equal to 1, and limit x tends to 0, log 1 plus x by x is also 1. Limit x tends to 0. Here there is no base e, just we get log e base e is equal to 1. Here e base a means again e base e. So you know these two, log a power x minus 1 by x also will be there. That is log a base e. These three are very, very important. Base e we have to discuss here. Log limit x tends to 0, e power x minus 1 by x is equal to 1. Limit x tends to 0, log 1 plus x by x is equal to 1. Limit x tends to 0, a power x minus 1 by x is equal to log a base e. These three are also very important formulae. By solving exponential and logarithmic function. Here fx and gx, f of x by g of x, where fx and gx are two real functions. Limit x tends to 0, the problem is in the form of 1 plus fx whole power g of x. 1 plus fx we convert into 1 plus fx power whole power g of x. Now limit x tends to 0, e power fx into g of x. Whenever a problem is converted in the form of 1 plus fx whole power g of x, or if you convert the given problem into limit x tends to 0, 1 plus fx whole power g of x, then finally e power fx into g of x. That means fx by, that means here 1 by g of x original, fx into 1 by g of x means fx into 1 by g of x means fx by g of x. This is important formula. Or you take let a is equal to this function, we apply logarithms also, we get this answer. If you take this, capital A is equal to limit x tends to 0, 1 plus fx whole power 1 by g of x. Now apply logarithm here. Log a base e is equal to limit x tends to 0, log 1 plus fx whole power 1 by g of x. Now by applying logarithmic notation, power here 1 by g of x into log 1 plus f of x. Now we multiply f of x and g of x, multiply and dividing. Now here log 1 plus x by x is equal to 1. Therefore limit x tends to 0, 1 by g of x into f of x. That means f of x by g of x. Now here this is log a base e. Now I want a log, we remove log here, e power f of x by g of x. This is very, very important formula. A is equal to e power, limit x tends to 0, e power f of x by g of x. Whenever a problem is in the form of 1 plus x whole, this is also x0 means infinity, 1 power infinity. Here x0, here x0, 1 power infinity notation. Now the exponential logarithm is 1 power infinity formula, infinity minus infinity or 0 into infinity problems are there in this exponential logarithmic functions. Now this is in the form of 1 plus x whole power 1 by x, in the sense x tends to 0, 1 plus 0 by 1 by 0. That means 1 power infinity. In the problem is in 1 power infinity, we apply limit extends to 0 e power f of x by g of x, we get the answer. This is in the form of 1 power infinity formation. A simple example of this 1 power infinity notation, if you take limit extends to 0 a power x plus b power x plus c power x by 3 whole power 1 by x. Now this is not in the form of 1 power infinity. Of course, here if x extends to 0, a power 0 1, b power 0 1, c power 0 1, 1 by 3, 3 by 3 1, here 1 by 0, it is 1 power infinity formation. If you substitute x is equal to 0, this is in the form of 1 power infinity. Now I divided this into 1 plus f of x. Our notation is 1 plus f of x. Here 1 plus cx minus 3 by 3 whole power 1 by x. See 1 plus fx whole power 1 by gx formation. Now limit extends to 0. See 3 into 1, 3 minus 3, 0, again we get the same function. I want to write this function into 1 plus x formation. Now here 1 plus, these 3 means 1 plus 1 plus 1. We apply 1 here and b here and c here by 3 whole power 1 by x. Now this is 1 plus fx whole power 1 by g of x. Now I apply e power a power x minus 1 by x, b power x minus 1 by x, c power x minus 1 by x into 1 by 3. Because e power fx into gx. Into gx means into 1 by x. That 1 by x can be written a power x minus 1 by x into b power x minus 1 by x into c power x minus 1 by x. Now this can be written as e power, limit extends to 0, a power x by x means log a base c, and this is called log b base c, and this is called log c base c into 1 by 3. Now here log a b c, because bases are equal, therefore e power log abc power 1 by 3. Now e and log both e cancel. Our answer is abc power 1 by 3. This is very, very important formula. Whenever the given problem is in 1 power infinity formation, first you convert into 1 plus f of x power g of x. Then finally we get e power fx into g of x. Here 1 by 3 is separated and fx into g of x, a power x minus 1 by x, b power x minus 1 by x, c power n minus x. This is log a, log b, log c. Now the power taken to that side, log abc power 1 by 3. The answer should be abc power 1 by 3, because here log e will be there and both the bases are same. Then abc power 1 by 3. This is also a very important problem. These type of models are very important. Whenever any difficult problem is given, we convert into 1 power infinity or infinity minus infinity. Whenever we observe the problem which is in the form, that is, that form should be 1 power infinity na, లేకపోతే infinity into infinity na, infinity in power 0 na, infinity minus infinity na, మనం extends to 0 సబ్స్టిట్యూట్ చేయగానే మనకు ఒక ఐడియా వస్తుంది. ఒకవేళ ఆ ఫార్మేషన్లో కనుక మనం ఉంటే, మనం ఇప్పుడు ఈ ఫార్మేషన్ తెచ్చుకున్నాం చూడండి, ఈ పవర్ ఎక్స్ ఇంటూ 1 ప్లస్ ఎఫ్ ఆఫ్ ఎక్స్ పవర్ 1 బై జీ ఆఫ్ ఎక్స్ అని, అట్లా మనం తెచ్చుకొని ప్రతి ప్రాబ్లమ్ని ఇప్పుడు ఈ 1 పవర్ ఇన్ఫినిటీ ఫార్మేషన్ ఉంది కాబట్టి అలా చేసాం. నెక్స్ట్ ఏదైనా సరే ఇన్ఫినిటీ బై ఇన్ఫినిటీ ఉన్నా, ఇన్ఫినిటీ పవర్ 0 ఉన్న అలా ఉన్న ఫార్మేషన్లో అయినా ఒక్కొక్కసారి మీరు ఎల్ హాస్పిటల్ రూల్ అప్లై చేయొచ్చు. ఏది అప్లై చేసినంటే లిమిట్స్ అప్లై చేయాలంటే నార్మల్ లిమిట్స్ ఎల్ హాస్పిటల్, లేదు ఈ ఫార్మేషన్ ఉంది అంటే 1+f(x) ఫార్మేషన్, లేదు 0/0 ఫార్మేషన్ ఉందంటే ఎల్ హాస్పిటల్ కానీ ఫ్యాక్టరైజేషన్ కానీ, లేదా రూట్లో ఉంటే రేషనలైజేషన్ కానీ, ఏదైనా మనం ఫార్ములాని అప్లై చేసేదాన్ని బట్టి లిమిట్స్ ఉంటాయి. లిమిట్స్ ఇచ్చే ప్రాబ్లం ఏదైనా జేఈ మెయిన్స్లో మనకి లిమిట్ ప్రాబ్లం ఇస్తే ఫస్ట్ అది దేనికి సంబంధించిందో మనం తెలుసుకోవాలి. ఆ ఫార్మేషన్స్ కనుక మనకు ఐడియా ఉంటే డెఫినెట్గా మనం ప్రాబ్లమ్స్ సాల్వ్ చేయొచ్చు. అంటే ఈరోజు ఈ అన్పవర్ ఇన్ఫినిటీ, ఈపవర్ ఇన్ఫినిటీ ప్రాబ్లమ్స్ మనం నెక్స్ట్ వీడియోలో కంటిన్యూ చేద్దాం. ఆ నెక్స్ట్ వీడియోలో కంటిన్యూ చేస్తే పాటు ఇక నెక్స్ట్ వీడియోస్లో మనం జేఈ మెయిన్స్ అడ్వాన్స్ సంబంధించిన సమ్స్ని కొంచెం నిదానంగా డిస్కస్ చేద్దాం. దీని తర్వాత మనకి ఎక్స్పోనెన్షియల్స్ ఉన్నాయి, e⁻x ఎక్స్పాన్షన్, log 1+x ఎక్స్పాన్షన్, sin x, cos x, tan x ఎక్స్పాన్షన్స్. ఇకంతా కూడా మనం ట్రిగ్నామెట్రిక్ ఫంక్షన్స్ కాబట్టి ఎక్స్పాన్షన్స్ నేర్చుకుంటే ఆ ఎక్స్పాన్షన్స్ మనం అప్లై చేయాలి. ప్రాబ్లమ్స్లో వాడు sin x, cos x ఇస్తాడు, ఆ ఎక్స్పాన్షన్ రాసి మళ్ళీ మనం e⁻x/x 0/0 ఇన్ఫినిటీ ఫార్ములా అప్లై చేస్తూ మనం మిగతా వీడియోలో మనం నెక్స్ట్ ప్రాబ్లమ్ కంటిన్యూ చేద్దాం. థ్యాంక్ యూ.